I think we'll just do number 6. Number 6 from last night's homework. I'm not going to do the whole thing, but I'll at least get set up. Should be plenty. It asks you to approximate the 5th root of 2. Is that right?
Yeah.
Yeah. So it's asking you to approximate the 5th root of 2. My hope, and I kind of put a little note up in the instructions, and maybe it wasn't quite enough, but to get you guys to write a function, polynomial function that has this as its solution. So something like x to the 5th minus 2 equals 0. Because if you were to solve that for x, you end up with x equals the 5th root of 2. So if you said y equals x to the 5th minus 2 as your function, then you should be able to use Newton's method to approximate the x-intercept of that, and the x-intercept of that should be the 5th root of 2, should be the value that we're looking for. Does that sort of make sense?
Yeah.
Yeah, so x sub n plus 1 then would equal x sub n minus f of x sub n, which would be x sub n to the 5th minus 2, and then over f prime, so y prime is 5x to the 4th, right? So 5x sub n to the 4th. And then since this is a polynomial, it's continuous for all real numbers, all we'd have to do is figure out when it's positive and when it's negative. So f of 1 is -1. And f of 2 is what's 2 to the 5th? 32. So 32 minus 2 is 30. So we'd see that we'd start with something between 1 and 2. Wouldn't really matter what. But x naught would equal, let's say 1.5, and we'd go down and get an answer. Does that help? Does that make sense?
Yeah, thanks.
Yeah, no problem. So same with the other ones. If you didn't get those ones done correctly last night, no worries. Like I said, I'm just grading the homework on completion. So go back through and make sure you can do them, and take a look at my answer keys when I post them up tonight, and you'll see what you should have gotten and all that. So any other questions on that?
How many iterations do you recommend to as the max number to write out?
I mean, sometimes it takes up to 10 to 15. Usually it only takes 4 or 5. So if you're going way beyond 15, chances are you could have started at a closer, better number, or you've made an error. Does that answer your question?
Yeah.
Okay, cool. Other questions? Anybody else?
For the one that was tan of x equals e,
yeah.
When I kept on plugging it in over and over to my calculator, it kept on jumping all over the place. So I don't know if I was doing something wrong or not.
Yeah,
just do tan of x equals e.
Yeah, so I'm not going to go through and plug it all in. I'll explain the problem with it, but tangent x minus e, it's got asymptotes in it, right? It's got all these vertical asymptotes going through there, and that's the problem with that one. So you need to, for that one, you got to pick a number that's pretty close to the actual value. Otherwise, when you try to draw the tangent line, the tangent line ends up hitting a really weird, it ends up hitting this function, this part of the function eventually, just super high up. And then once you do that, you end up getting even further up on the next piece of it, and then even further up on the next piece of it. So it's because of the repeated vertical asymptotes that becomes a problem. So I think the final answer for that one ended up being somewhere in the 1.2s, and you needed to start somewhere around 1.5 maybe, or else it didn't end up working. Somewhere between 1 and 1.5, or else you ended up getting these ridiculous answers. So does that at least answer your question about why that didn't work out?
Yeah, so what should we do to fix this? Should we just try different numbers?
Yeah, just start with a different value that's closer to what you think the actual value is. So you can look at it on a graph and be like, it looks like it's really close to the 1.1. It's not closer to 2, it's closer to 1, so start closer to 1, that kind of thing. But on the quiz that we have on Friday, which will have a Newton's method problem, this won't be an issue. It'll be a pretty straightforward one. There won't be any asymptotes or anything on it, and you don't need to really need to worry about it. So. Yeah, just start with a closer number, and like I said on the quiz, it won't affect you on the quiz. So, is that good or no?
Makes sense.
Okay. Anybody else? Anything from the homework? All right, so let's get started. I think we only had a chance to do one optimization problem yesterday. Is that true? We just did the x squared plus 1, right? Okay, so today we're going to start with this fun one here. We're going to take one arch of the sine curve, and we're going to inscribe a rectangle underneath it and find the largest area of that rectangle and what dimensions give us that area. So the first thing we need to know before we even start thinking about this is, what does it mean to inscribe something under a curve? So I'm going to draw exactly what this means. So here is one arch of my sine curve, right? We're just going to say this is the one arch of my sine curve. And to inscribe a rectangle in it means that the rectangle, wow, that was really bad, touches the sine curve at the same heights here as those same vertices that touch it, and then is also adjacent to our x-axis, touching our x-axis. Okay, so that's what it means to inscribe it underneath the arch of the sine curve. It means it's between that one arch, that piece that's above the x-axis, and then it lies on top of the x-axis. So that's what it means to inscribe something into a curve. And so this is what we've got. We've got a sine curve. Mine's not very well drawn, but we've got a rectangle inside of it. And there's lots of different ways I could have drawn this rectangle, or I could draw one that looks like this. It's a little bit taller and skinnier, or one that's shorter, right? Well, hopefully it actually goes along the x-axis like I said it should. Right? Lots of different ways to draw rectangles in there. We want to know which one has the largest area. So what do we need to do? We need to write an equation to represent the area of a rectangle, right? So before we even bother to label anything, what's the area of a rectangle? It's the base times the height. True? Yeah, hopefully. So we want to figure out what B and H are, all in terms of probably X. I will call this X, and we'll call this Y. Right? We want to figure out what B and H are in terms of X. So here's the base, and here's the height. How are we going to relate those to our function and relate those to, X on our coordinate system? Any ideas?
The coordinates of where it touches the sine curve.
Okay, what about those? What are they?
Well, they give you like an x, y, and then an x, y, and the y is just like, it's just that because it's on the x-axis. But you could do like x2 minus x1, and that give you like the base in terms of x.
I'm sorry, say that again. I was having to talk to my son about something. Give me one second. Okay, sorry about that. Say what you were saying again.
So like the coordinates where the rectangle would touch the sine curve. So like the base would be x1 minus x2, but then y would just be like the y value of the coordinate, since the base of it's on the x-axis.
Okay, I see what you're saying. So you want to call this x1 and this x2? Is that what you're saying?
Yeah, basically.
Okay, so that's introducing a lot of variables, though. So I like your idea. We're going to work with your idea to kind of develop something that's all in one variable. Because if I call something x1, I call something else x2, and then I've got to find some way to relate x1 and x2 to each other. So when we talk about an x value, where do we measure that x value from? Where do x values start from?
The origin.
From the origin, right? So if I'm going to go over some x amount, I start at the origin and go over, let's say, x. And so this way, I should, with any luck, be able to figure out what this distance is only in terms of x. Because what do I know about the sine curve? Where does it cross the x-axis over here?
At pi.
Right, at pi. Okay, and a sine curve is symmetric, isn't it? So if I've gone over x here for my rectangle and these heights are the same, what should this length here be also?
X.
Also x.
Should also be x. Okay, so what does that tell me that my base should be? And we don't even need a second variable for it.
Pi minus 2x.
Our base ought to be pi minus 2x. Now here's where we're going to use that idea you were talking about, where you were saying this should just be the value at your x1. Well, now this x1 is no longer an x1, it's just an x. And so the value of our function here should be sine of x. That point up there should just be x comma sine of x. Does that make sense? And so if that point is x sine of x, what should the height be?
Sine of x.
Should just be sine of x. Everybody good with that setup of that problem there? Getting the base and height all in terms of one variable?
Wait, what point are you labeling x sine of x?
This point is x sine x.
Okay, why would the y, why would the height be sine of x?
Well, what is this curve? This curve is y equals sine x, right? So if I'm over at x equals 1, then the height is the sine of 1, right? Or if I'm at x equals pi over 2, the height is the sine of pi over 2. So if I'm at x equals x, then the height is sine of x.
Oh, okay.
Does that make sense? Yeah. Everybody good there or no?
Great.
All right. It's over here so it doesn't get in my way. So our area is now pi minus 2x times the sine of x. So if we want to figure out when that area is at a maximum, when it is the largest value, what do we have to do with a function to find its max?
Take the derivative.
Perfect. So a prime ought to be pi minus 2x u times the derivative of v, so cosine x, and then plus the sine x times the derivative of pi minus 2x, which is negative 2. Or a prime is, we'll say pi minus 2x times cosine x minus 2 sine x. Oops, sorry, a prime is. And so in order to figure out the actual x values at which this is at a max or a min, and in our case a max is what we're looking for, what do we need to do with this? We need to set it equal to 0, and we need to see when it's undefined. So first off, is a prime ever undefined?
No.
Sorry, trash truck's going by. I can't hear anything at the moment. Is A prime ever undefined?
No, it isn't.
I think you said never, so we'll say never. And then we also want to know when is A prime equal to 0. So normally we try to solve it algebraically, but this function pi minus 2x times cosine x minus 2 sine x is going to be too difficult to solve algebraically. So we'll say that A prime is equal to 0 whenever x equals whatever you guys tell me from the calculator. You should be able to go into your graphing calculator and figure that out. Right? So let's do that. So pi minus 2x times cosine x minus 2 sine x. You guys all got that in your graphing calculator, you graphed it. I got mine zoomed in already, but if we go back to the standard look of it, we got a lot of places where that's equal to 0, don't we?
Yeah.
Yeah, so first of all, what about all these negative ones? Is x ever going to be negative?
No.
No. So we're interested in these values where it's crossing over later. If we think about our function here, what's the largest value that x could be? We know it's got to be greater than 0, but x needs to be less than what?
Pi.
In fact, it's probably got to be even less than not just pi, but less than pi over
2.
2, right? Because pi minus 2x, right, needs to be, yeah, or sorry, not pi minus 2x, but if I take an x value out, I'm trying to take two different x's out from pi. If any of them are, if those x's are more than pi over 2, then we're kind of out of luck there. So if we go back in, we could zoom this in, or we could change our window. So if we just bring our cursor over sort of in the middle of around 2-ish and zoom in. We should be able to figure out what these values are and see if both of them or just one of them is less than pi over 2. So we'll calculate our 0, starting with something that's to the left of that intercept, and then something to the right, and it gives us 0.7104627. And if we do the other one, it gives us what? 2.43. Now, is that more or less than pi over 2?
More.
That's more than pi over 2, so we can ignore that one. So we know that this one over here is our only option. So if we make a sign chart with this 0.7104627 value on it, I don't really need to plug anything in because I'm already looking at the graph. My derivative to the left of 0.7104627, to the left of this point that I got here, is positive or negative?
Positive.
My derivative is positive. So if my derivative is positive, then that means that this is increasing. And then to the right of that value, my derivative is negative, which tells us that our function is decreasing, which proves to us that this is a maximum area and not a minimum area when x is 0.7104627. Good or no? So far? We haven't actually answered the questions yet, but Any questions, any problems with that, any issues with that? No? Everybody good? All right, so then it wants to know what are the dimensions, so we got to figure out what's the base and what's the height. So the base is pi minus 2 times that. So base equals pi minus 2 times 0.710467. And our height is equal to the sine of 0.710467. And our area is equal to those two things multiplied together. So with any luck, you guys can tell me what that all comes out to be. So make sure you're in radians. I'm in radians. Before you do the sine one, we've got pi minus 2 times 0.710, was it 46 or 6427? 4627. So that one's 1.720667254. This one comes out to be the sine of that. .65218. 45953. And our area should just be those two things multiplied together. And for your final answer, you can round to 3 decimals if you'd like, 1.122. And we had no units there, so units squared. Everybody good there?
Yeah.
Perfect. Any questions or no? All right, let's take a look at this next one. So we're going to take a sheet of 10 and we're going to cut off squares of each side from it to make an open top box. I'll let you guys take a second to read through it. And why don't you take like a minute, read it, and see if you can draw a picture to represent what we're doing, and then we'll work on labeling it together. All right, ready? You guys got a picture? We work on labeling it. Here's our sheet. "25" by 20 inches. And what are we doing? We're taking the corners off, congruent squares from each corner. And we want to know how large should those squares be to make the box hold as much as possible. So in essence, we're looking for what is the maximum volume here. So what are we going to label? So we got these little flaps, right? They're going to fold up and we're going to make a box. What's the volume of a rectangular box?
Base times width times height.
Yeah, or length times width times height, base times width times height, whatever you want to call it. Okay. And how much are we cutting off? Well, that's what we're trying to figure out, right? How large are these squares? So that's should be our variable, right? Let's figure out how much to cut off. So why don't we call this x, making that also x? And what does that tell us about our length and our width?
One is 20 minus 2x, and the other is 25 minus 2x.
Exactly, right? Because we've got the full 25 inches, but we've cut off x from each part of it, and we've got the full 20, and we've cut off x on each side of it. And what does it tell us about the height then?
Just x.
Should just be x, right? Because we're going to fold that flap up, and the height of that's going to be x. So there we go. We got length, width, and height that we got them all in terms of x. So volume has now become 25 minus 2x times 20 minus 2x times x. Or if you distribute that all through, we're going to have a 4x squared times an x, which is 4x cubed, a minus 50x and a minus 40x, which is minus 90x times an x. So minus 90x squared. And then the 20 times the 25 is 500 x. Good or no? Any questions, any issues with that?
Can I have one?
All right, so if we want to know when is that volume at a max, what do we need to do?
Take the derivative.
Take the derivative of it. So that gives us v prime, which should be equal to 12x squared minus 180x plus 500. So was v prime ever undefined?
No.
Nope. And what about when v prime equals 0? That's the other thing we'll need to figure out. So v prime equals 0 if, what was it, 12x squared minus 180x plus 500 equals 0. Looks like we can divide all those by 4. So that'd be 3x squared minus 45x plus 125 equals 0. And unfortunately, that doesn't factor, so we'll have to use the quadratic formula on it. X equals 45 plus or minus radical, let's see, what's 45 squared? That ought to be 45 squared. Is that 2025? Does that sound right?
Yeah, that's it.
Yeah. Oh, good. I can still do arithmetic in my head. minus 4 times A times C, so minus 4 times 125 times 3. Guess I could have done that one too, but oh well. All over 6. And so we end up with x equals 45 plus or minus, let's see, this becomes root what? That's 1500, so 525 inside of there. And we should be able to simplify root 525 by dividing it into 25 times 21. So 5 root 21 over 6. Everybody good with that? Or no?
Yeah.
Okay. John, to answer your question easily, if you're looking for an adverb to answer that question. So then we got to figure out, because we can't have a plus or a minus, right? We can't have two different x values that are going to give us a maximum volume. So we got to figure out which one makes sense. So let's think about the values that x could even be. X got to be greater than 0, right? We know that. What does x need to be less than? Similar to that last one, x needs to be less than something. What is that?
10.
Yeah, it's got to be less than 10, because if I'm cutting off 10 from each side, well, then I'm going to be cutting off the entire width, right? So it's got to be less than 10. So is 45 plus 5 root 21 over 6, or 45 minus 5 root 21 over 6 between 0 and 10?
Yeah. 45 minus.
Yeah, the 45 minus. The 45 plus 5 root 21 over 6 is greater than 10. So we'll choose x equals 45 minus 5 root 21 over 6. And we could either use a sign chart for this to prove that it's a max, or we could take a second derivative. And since this one has a really easy second derivative to take, let's do that. What's v double prime equal? 24x minus 180. Yeah. If I'm going to multiply this thing by 24x, well, I'm dividing it by 6. So that's really just like multiplying it all by 4. So really, all that really matters is 45 more or less than 5 root 21, and 45 is more than 5 root 21. So if we're going to evaluate this, let's see. Oh, sorry. Yeah, so then we got to subtract 180 from it, right? So if we subtract 180 from that, what do we end up getting? Positive or negative? You guys got to calculate. I'm not going to do that one in my head for you, John.
Negative.
You guys have to be negative. That's good. It should come out to be negative, right? Because if it comes out to be negative, that means it's a max. And that's what we wanted, was a max when we cut off 45 minus 5 root 21 over 6 inches. And I'm not going to go through and do all the arithmetic here. We want to know what's the maximum volume. Well, the maximum volume, you just plug that number back into your original equation and find that. Any questions on that or no?
Yes. Can you go back to the other page?
Okay. Question on that, or you just want to look at it for a second?
Yeah. So I get for the volume formula, I got like the 25 minus 2x, 20 minus times 20 minus 2x, but how did you get the times x at the end?
So the x is the height of it. So right, we're taking
yeah.
4 little flaps and folding them up, and they're each x.
Makes sense. All right.
Cool. Other questions on that one or no? Anyone?
Are we required to like show a proof for that it's an extrema? Like if it's a max?
You got to show that it's a max, not a min, because it asks what's the max volume, and if you don't prove that it's a max rather than a min, then you haven't shown that it's a max. You've just shown that there's some sort of extrema, maybe, when this occurs, right? Because sometimes even if the first derivative is 0 at a point, that doesn't mean that it's a max or a min. It just means that it could be. Sometimes we found that it wasn't, right?
Yeah.
All the other functions we dealt with. So you got to show it. Otherwise, you're wrong. And sometimes you might end up having a max and a min on your interval. So you got to figure out which one's which. So yeah.
Okay.
No matter what, if it asks for a max or a min, you always have to either use the second derivative test to prove it, or like we did in the first one, you got to use a sign chart to prove it. Either way is fine, but you got to do one or the other. Everybody good or no? All right, let's take a look at this next one here. We're going to design a 2-liter can in the shape of a cylinder, and we want the dimension that we use the least amount of material. So if we're thinking about the amount of material, what does that represent in math terms? What is material for some 3-dimensional shape?
Surface area?
Surface area, exactly. So we want to know what's the surface area of a cylinder. Well, what is the surface area of a cylinder? It's got a top, it's got a bottom, right? And it's got the lateral surface area, the sides. So the top and the bottom are each what? What is the area of the top and the area of the bottom?
Pi r squared.
They're both pi r squared, so that'd be 2 pi r squareds. And what about the lateral surface area going around?
2
2
pi
pi
r
r h.
2 pi r, or circumference, right? Circumference of the base times the height. That's the worst thing I've ever written in my life. All right. Good or no? Everybody okay with that formula? Okay, now what's the problem with that formula? And how is it different than all the other things we've dealt with so far with our optimization?
Well, it needs R, but the only info it gave you was volume.
Okay, it needs R, all it gives us is volume, but what else is going on in this surface area equation? Besides just an R, we've also got an H, right? Is that what you meant by it needs R?
Oh yeah.
Yeah, so we've got this H in here that's a problem. So luckily they've given us a volume. What do we know about the volume of a cylinder? It ought to be pi r squared times H, and it ought to equal 2,000. Everybody agree with that?
Yeah.
So what does that tell you about H? H better be 2,000 divided by pi r squared. Good?
Yes.
So now we should be able to use this, plug it in for H, and say that our surface area, all in terms of R, if this is a 2,000 cubic centimeter can, is 2 pi r squared plus 2 pi r times 2,000 over pi r squared. Good or no? I hope so. We'll simplify that down. 2 times the 2,000 is going to give us 4,000. Pi's will cancel. R over r squared is r to the negative 1. Everybody good with that being our equation for our surface area? Okay, so if we're looking to have the least amount of material, we want to minimize this, which means we need to find the minimum, and we'll use a derivative to do that. 4 pi r minus 4,000 r to the negative 2. And in order to figure out when that equals 0 and when it's undefined, it'll probably be convenient to have a common denominator. So we'll multiply the 4 pi r by r squared over r squared. 4 pi r cubed minus 4,000 over r squared. And when is this undefined?
R equals 0.
Yeah, r equals 0. But that doesn't make a lot of sense, right? I mean, if we got a can, it's not going to have a radius of 0. We know that r has to be greater than 0. So we can ignore this. And this is a nonsensical value in our particular problem. So then all we care about is when does this equal 0? So we'll say that a prime equals 0. If what was it, 4 pi r cubed minus 4,000? Is that right? Yeah. Equals 0. So solve for r. We've got r cubed equals what? 1,000 divided by pi, or r is equal to 10 over pi to the 1/3 cube root of pi. Good or no?
Makes
Okay,
sense.
so, all right. So if r is 10 over the cube root of pi, we need to then show on a sign chart, let's say, that this is either a max or a min. So what's 10 over the cube root of pi equal approximately? You got a calculator in front of you, I assume.
6.82784.
6.82784. Okay, good enough. So picking a value that's less than that's pretty easy, like 1. We got to plug it into the full derivative. So if I plug in stuff to the denominator, what can you tell me about the denominator always?
Always positive.
Always positive. So we can actually ignore the denominator. All we care about is the numerator. So 1 cubed is 1. So we have 4 pi minus 4,000. That's definitely negative. Plug in something more than 6.8, like 9. This becomes 9 cubed, which is 729 times 12. Well, that's clearly more than 4,000. I know it's not exactly 12, but it's about 12. And that's clearly more than 4,000. So if we subtract 4,000, we're going to stay positive, and we have a minimum, which is what we wanted. And the question then asks, what are the dimensions? So this time we'll go in and we'll figure it out. The dimensions are just the radius and the height. Our height is 2,000 over pi r squared, and we've got our radius already. So we'll say height is 2,000 divided by pi times that radius squared. And what does that height come out to be? 2,000 divided by 10 squared, that's 2,000 divided by 100, which is 20. And then we've got pi divided by pi to the 2/3, which would be pi to the 1/3, or the cube root of pi. And let's see, those were in centimeters, I believe. Any questions or issues with that? Starting to get the hang of these a little bit.
A little bit.
All right, let's do some more. We got 2 more we're going to do today. So I'll give you guys a second to read that one, and then we'll talk about it. All right, so what do we have going on? We got a sphere, right? So there's our sphere. And inscribed within that sphere is a cylinder. So there's a lot of different ways we could draw this cylinder, but I'm going to draw just some generic cylinder. There's our cylinder. Obviously, we could have one that was shorter and fatter or taller and thinner, but we're just going to draw one that's sort of in the middle here. So we got a sphere with a cylinder inscribed in it. I know my picture is not perfect, but these should be lined up perfectly so that the sphere and the edge of the cylinder are touching in all these places. Everybody good with the picture so far?
Great.
Okay. We're only given one piece of information other than this, that radius of the sphere itself is 10 centimeters. And we want to find the maximum volume of the cylinder. So first off, what's the generic equation for the volume of the cylinder?
Pi r squared h.
Pi r squared h, good. And then how are we going to deal with that? We got to somehow relate r and h to each other so that we can replace one with the other. But how are we going to do that? Let's draw r and h on here for the cylinder. There's r, right? And let's see, here is h. How are we going to relate those? Any ideas?
Pythagorean theorem?
How?
Well, it says it's a right circular cylinder, so the radius, if you drew it from the dot to like the corner of the cylinder, it'd be like the hypotenuse is 10, and then you'd know that the leg, like the leg of which is the radius of the cylinder, would be like the shorter leg, and then you can have the height and just double what you get, and that'd be the total height of the cylinder.
All right, so you're saying we're going to draw a little triangle like this, basically? With
Yeah.
the being 20, sorry, not 20, being 10, because that's our radius. So that would be effectively this right triangle, 10, r, and half the height. Everybody agree with that?
Yes.
Okay, so let's relate these then. We know that h over 2 squared, that's h squared over 4, plus r squared is equal to 100. We've already got an r squared in here, so maybe this time we should just replace the r squared with what we got here. So r squared is 100 minus 1/4 h squared, and we'll get that our volume is pi times 100 minus 1/4 h squared times h. Or distributing it all through, volume is 100 pi h minus pi h cubed over 4. Everybody good with that or no? And if we want the maximum volume, we need to take a derivative. So 100 pi minus 3/4 pi h squared. And two questions about this. When is it undefined? It's never undefined, right? And when does it equal 0? Pi minus 3/4 pi h squared. So when does that equal 0? Just solve that for h. 3 pi over 4 h squared equals 100 pi. We divide by pi, the pi's cancel. We get h squared equals 400 over 3, or h is plus or minus 20 over root 3, but obviously we're not going to have a height that's a negative 20 over root 3. So we just have height is 20 over root 3. Everybody okay with that so far? Yeah, no, maybe.
We're good.
Okay. So we got two options. One is a sign chart to prove it's a max or a min, and the other is a second derivative test. And since this one has such an easy second derivative to find, I would suggest that v double prime is equal to negative 6/4 or negative 3/2 pi h. And if we evaluate v double prime at a positive number, 20 over root 3, what do we get? We get a negative number, so it's less than 0, which tells us this is a max. That's what we wanted, was a maximum volume. So our maximum volume occurs at h equals 20 over root 3 centimeters. And if we wanted to figure out the actual volume, which is what the question's asking, we just plug it in. V of 20 over root 3 equals what? So here's our volume equation. If you plug in 20 divided by root 3 to that, what do you get? Did I type all that in right? Clearly not. That was supposed to be a pi h. No, it was not supposed to be a pi h squared. What did I type in wrong? Shouldn't have been a 3 there. There we go. John, this is why I normally just do all this in my head. There we go. 2,418.399. Is that what you guys got?
Yes.
Yeah, you guys could have just told me that. Any questions on that? Everybody good? Any issues? Everybody all right with optimization so far? We're going to do one more. All right, last one of the day. I'll give you guys a couple of minutes to take a look at it and see if you can get it set up. In fact, you guys want about 5 minutes to just try and do the whole thing on your own?
We can't
I don't
see
think
anything.
you can see your screen.
Oh, I still have it on the calculator. Sorry. You guys want about 5 minutes then now that you can see it, to try and do it?
Sure.
All right, sounds good. So 5 minutes or so, and then we'll talk about this one. And apparently I forgot to resume the recording for that entire last problem. So I'm just gonna real quickly once more say everything we did. so that it's on the video. Sorry about this. So we found our cost equation by finding the 2 pi RH, which is the lateral surface area, times the cost of 5, plus the base's area, which is pi r squared, times its cost, which was 15. Simplified that down by replacing the h with our 24 over r squared, which we got from the original volume. Took the derivative, got a common denominator, and looked for when c prime was undefined, which was at r equals 0, which made no sense, and looked for when it was equal to 0, which was at r equals 2. Did a sign chart, found that it was a minimum, and then solved for h as well.